Every spacecraft design process starts with a dream: maximum capability, minimum cost, and flawless reliability. But in space missions, unlike real life, you cannot have it all. Every decision comes down to trade offs, and three really important ones are power, mass, and reliability. Let's start with mass and power. If you add bigger solar panels, you get more power, but solar panels add mass. More mass means you need a larger rocket, and a larger rocket means higher launch costs. So, space systems engineers are constantly asking, do we really need this much power, or can we design the payload to consume less? This is why some missions use incredibly efficient electronics and low powered payloads. It's actually quite survival maths. Now, let's talk about mass and reliability. One way to make a system reliable is through redundancy. You duplicate the components, two batteries instead of one, three computers instead of two, but every backup again adds mass. So the trade off is kind of brutal. Do you make the spacecraft lighter or heavier and more expensive but safer? That's why systems engineers use something like selective redundancy. Critical systems like attitude control get backups, while less critical systems, maybe a system that is being sent for in-orbit demonstration, may not receive a backup. Finally, power versus reliability. High-power systems are often more complex and more failure-prone. For example, running a radar payload may demand huge bursts of power, but if the power system falters, the mission objective will anyway not be met. Sometimes engineers deliberately cap the power budget to avoid creating fragile systems. That's why many small satellites survive with tiny power margins. Simplicity can mean high reliability. So the next time you see a spacecraft mission, remember this: behind every design is a not so silent tug of war among power, mass, and reliability. Because a spacecraft is not about the best design, it's the best compromise for achieving the mission objectives. Now, I want to hear from you. If you were a space systems engineer, where would you compromise? Would you cut down on mass, reduce power, or risk reliability? Drop your thoughts in the comments below and stay subscribed to this channel for more videos on space technology.